Hello students, welcome to MGC Learning. I am Manju Dilip. Today I am going to start with the 12th standard mathematics topic probability distribution part 2. In the previous video we have discussed probability mass function and solved some questions. So today we are going to discuss probability distribution function and solving exercise questions based on that. Also discussing cumulative distribution function, expected value and variance of a random variable definitions. So cumulative distribution function. The cumulative distribution function CDF of the discrete random variable x is denoted by capital F and is defined as follows. F of x is equal to probability of x less than or equal to x is equal to sigma xi less than x, where p of x is equal to xi, or you can write this as sigma xi less than x, pi is equal to sigma xi less than x f of xi, where f is the probability mass function of the PMF of the discrete random variable x. Expected value and variance of a random variable. Expected value or E of x is the representation for that. It is also called mean or arithmetic mean. So it is denoted by mu, the alphabet mu. So let x be a random variable whose possible values are x1, x2, etc. xn occur with probabilities p1, p2, etc. pn respectively. Then the expected value or arithmetic mean of x denoted by E of x or mu is defined by expectation of x is equal to mu is equal to sigma from I equal to 1 to n xi pi is equal to x1 p1 plus x2 p2 plus etc. xn pn. So expectation of x is the product of all the xi and pi values and summation of that, and it is denoted by mu. It is also called arithmetic mean. In other words, the mean or expectation of a random variable x is the sum of the products of all the possible values of x by their respective probabilities. So all xi values and their respective probabilities, then the product of this you have to take, then adding all these values you will get expectation of x. You have to by heart this formula. Next one, variance of a random variable. Definition: let x be a random variable whose possible values are x1, x2, etc. xn occur with probabilities p1, p2, etc. pn respectively. The variance of x is denoted by variance of x var x or sigma x square is defined as sigma x square is equal to variance of x is equal to sigma from I equal to 1 to n xi minus mu whole square into pi. In the place of mu, you can substitute the expectation of x also. The non-negative number sigma x, variance means sigma x square. So if you are taking the square root of variance of x, you will get standard deviation of the random variable x. Standard deviation SD, that is the short form abbreviation for that. We can also use the simplified form of this equation to find variance of x. Sigma I equal to 1 to n xi square pi minus sigma I equal to 1 to n xi pi whole square. This is expectation of x whole square, or you can represent like this also. Variance of x is equal to expectation of x square minus expectation of x whole square, where expectation of x square is sigma I equal to 1 to n xi square pi. So if we are writing this formula, you can use this one for finding this one. That this way also you can write this formula. These are the simplified formulas. Now we are solving some questions based on probability distribution functions. So let x represent the difference between number of heads and number of tails obtained when a coin is tossed 6 times. What are possible values of x? Here x is representing what? X is representing the difference between the number of heads and number of tails obtained when a coin is tossed 6 times. So here a coin is tossed 6 times. So minimum possibility, if you are equally taking 3 heads and 3 tails, 4 heads and 2 tails, so I can write this as 6 heads or 0 tails, 5 head 1 tail, 4 head 2 tail, 3 head 3 tail, 2 head 4 tail, 1 head 5 tail, 0 head and 6 tails. These are the possible outcomes. So x can take values if 0 heads are there. Here we are representing x denote the difference between the number of heads and number of tails. So difference, if you are taking 6 minus 0 is 6, 5 minus 1 is 4, 4 minus 2 is 2, 3 minus 3 is 0. So minimum value is 0 and maximum value you are getting is 6. That is the x can take possible values like set 0, 2, 4 and 6. Second question, an urn contains 5 red and 2 black balls. 2 balls are drawn at random. X denotes the number of black balls drawn. What are possible values of X? Given an urn contains 5 red and 2 black balls, and we are taking only 2 balls at random. So let X denote the number of black balls drawn. So X can take values. No black balls are getting into drawn, or one black ball getting, or two black ball getting. These are the maximum possible outcomes of this one. So possible values of x are, if we are not getting any black balls, 0 will be the outcome. So if we are getting one black ball, 1, or maximum 2 in 2 drawns, 2 black balls. So 0, 1, 2 are the possible outcomes of x. Next question, find the probability distribution of number of heads in 2 tosses of coin. And second question, number of tails in the simultaneous tosses of 3 coins. And number of heads in 4 tosses of coin. So number of heads in 2 tosses of a coin, that is the first question we are considering. So the sample space for that is 2 coins are tossing, so 2 heads, 1 head, 1 tail, tail and head, and tail and tail. These are the possible outcomes of the sample space. So let x be the number of heads in 2 tosses of a coin. So x can take values as 0 heads are getting. In this tt you are getting 0 heads, and th and ht we are getting 1 head, and in hh you are getting 2 heads. So possible values of x are 0, 1 and 2. Probability of x is equal to 0. So number of heads of getting 0 is probability of only tt, the set tt, that's equal to 1 upon 4. Only one time you are getting out of 4 outcomes, so 1 upon 4. Similarly, probability of x is equal to 1. One head is getting in either ht or th. So probability of set th or set ht, that is 1 upon 4 plus 1 upon 4, that is 2 upon 4, that's equal to 1 upon 2. Next is probability of x is equal to 2, that's equal to probability of 2 heads are getting in only one case, that is set hh. Both the values are head, so that's equal to 1 upon 4. Only one chance we are getting like that, so 1 upon 4. So probability distribution for this is x is equal to 0, 1, 2. These are the possible values of x, and probability of x is equal to first case, if x is equal to 0 we are getting 1 upon 4. For probability of x is equal to 1 we are getting 1 upon 2. For x is equal to 2 we are getting 1 upon 4. So this is the probability distribution of the number of heads in 2 tosses of a coin. Next one is number of tails in the simultaneous tosses of 3 coins. So 3 coins are tossing, so maximum outcomes are written in the sample space. So S is equal to HHH, HTH, HHT, THH, HTT, THT, TTH and TTT. So let x denote the number of tails in the simultaneous tosses of 3 coins. So x can take values, all the values are, all the outcomes are head, then getting a tail is 0 here. Chance probability of getting a tail is 0. So similarly in this cases, this one and this one, we are getting only one tail. So one tail is one value, and 2 tails are in 3 cases we are getting 2 tails, and maximum number of tails getting is 3. So these are the values we can take for x. So probability of TTT is only one time we are getting in the sample space. So 1 out of 8 outcomes we are getting 1. So 1 upon 8 is the probability for that. Probability of getting x is equal to 1. That means only one tail is occurring in 3 cases, THH, HTH and HHT. So out of 8 outcomes, 3 possible outcomes will come in that. So 3 upon 8. Similarly, for 2 tails HTT, THT and TTH, we are getting 3 outcomes again out of 8. So 3 upon 8. So probability of TTT, all the 3 coins are showing tail is only 1, so 1 upon 8. So x can take 0, 1, 2, 3, and probability of x is equal to x is 1 upon 8, 3 upon 8, 3 upon 8 and 1 upon 8. The next question is given as the homework question. You have to solve it to find the probability distribution of number of heads in 4 tosses of coin. And another question also given as exercise question. You have to solve it. Thank you.